So I wanted to do a weak acid problem where the 5% rule does not work and what you have to do in that case. But before I do that, I wanted to come back to this previous problem and just show you, you can check your work. It's always good to double check your work, right? So I have my answer here, right? And so what you can do is you can plug that back into this equation, and you should, just to check this, see that you get 6.2 times 10 to the negative 10th. Okay. My calculator go. If I take the 7.87 and square it, because it's times itself. Oops. Try that again. 7.87 times 10 to the negative 6. Square that, get that number, and then divide that by 0.1. It gives me 6.19 times 10 to the negative 10th. So it gets me back to that. So it's a good way to check to make sure you've done it correctly, especially for the 5% rule. So here's another problem where the 5% rule does not apply. Okay, so I'm going to try to find the pH for the 0.1 molar the acid. This is HClO2, which of course is the chlorous acid. That's the that is the chlorite ion, so it's chlorous is the naming. I don't know if we did naming. Maybe someone can comment in excuse me, the Google Classroom to remind me if we've done naming this year. But anyway, so we have our acid here. I'm just going to simplify this, HClO2. Okay, it's weak acid, so it actually exists in this. Simplify this H plus ClO2 minus. If I check the chart, okay, my Ka, this is always the expression. Ka is the concentration of your products times multiplied by each other divided by the concentration of the reactants. Okay, of course, this would be the initial concentration of this. Okay, so when I set up my rice table, here's my reaction. This is why it's called right, and then put my ice down here. This is why sometimes it's called the ice table as well. So my initially for this I have HClO2, I have a 0.100. Okay. Initially for my H plus, I don't have any. Close to none. Change, this is going to go down by some amount. Unknown amount, this is going to go up by some amount. This is going to go up by some amount. So at the end, this is going to be 0.100 minus X. This is just going to be X. The concentration of this is just going to be X. Okay, so look at it. These are this chart is about concentrations. Okay, so I want to plug these in here. So this would be X, X, and this would be 0.1 minus X. Okay, Ka for this, look it up in the appendix there in the back of the book. Appendix 22 is 1.2 times 10 to the negative second. Okay, so plug those all in there. You get just give myself a little bit more room here. Maybe not. Myself just a little bit more room. Come in here, and so my 1.2, my Ka, 1.2 times 10 to the negative second, confused, is equal to my unknowns, x squared over 0.100 minus x. Okay, so if we do the simplification, you always start with this, makes it easier. Just imagine that is so small. Okay, so we multiply these two numbers together, take the square root of that. So that would be try it this way. So the square root of 0.1 times 1.2 exponent 2 equals if gives me that, so then I have to take the square root of that, gives me x. It says that x equals 0.035 0.035. Okay, so if I divide that by 0.1 multiplied by 100 gives me 34%, bigger than 5%. So I can't use this 5% rule. Okay, this isn't small, it's small enough. So that means is I actually have to use some good old mathematics. Okay, because I have two unknowns. Well, I have x and x squared minus x, right? So what I have to do is have to solve this for x, and I have x squared and I have x unknowns here. So what we have to do is set this equal to 0 and use the quadratic equation. Okay, so what I'm going to do is I'm going to multiply, cross multiply here. That would give me 1.2 times 10 to the minus 2 x, right? Minus, I guess it would give me that's going to give me 0.1 times 1.2, so 1.2 exponent to negative times 0.1. I guess I didn't need a calculator for that, but it's going to give me 1.2 times 10 to the negative third, right? And then minus 1.2 times 10 to the minus second x, right, is equal to x squared. I want to set this all equal to 0, so I'm going to add 1.2, so that'd be x squared plus 1.2 times 10 to minus 2 minus 1.2 times 10 to the minus 3. Okay, so I have my ax plus ax squared plus bx plus c equals 0, right? And so then I want to use my quadratic equation, which I have. So there's that. This is also in the appendix, but the equation for quadratic formula is x equals negative b plus or minus square root b squared minus 4 times ac, all divided by 2 times a. Okay, so that's the equation. So I want to plug, this is a is 1, b is 1.2 times 10 squared there, so that would be, so it actually should be x here, right, minus 1.2, okay? So you plug that in, and what you get is, because it's plus or minus, you get two answers, right? It's plus or minus. So you get two different answers. Plug that in, check all the signs, see if you can get that. But for this problem, what you get is negative. You get two answers. You get one of them is negative 0.039, or you get 0.028. Plugging it in there, okay? So how do you know which one the answer is? Okay, so you always get two answers from this quadratic equation. There's always going to be one that doesn't make sense physically, okay? Could the concentration be negative? Could this x go from, after this dissociates, could this go into a negative direction? It can't. It's possible to have negative number of things, okay? So we know that's not the answer, so here is our answer. Okay, and so that would be the O8H plus. Okay, so that's your H plus. Concentration over H plus would be 0.028. Okay, and so now we want the pH. We want to take the minus log of this. Okay, so 0.028, and we'll take the log of that and then change the sign. So that would give us a pH of 1.55. 1.55 pH, pretty low, even on this scale. And of course, we could do the double check. But if we take this, plug it back into here, you get 0.028 squared, and divide that by 0.1. Oops, what happened there? Clear that out. 0.028 squared, that divided by because it's, we have to also account for this here, right? So we don't want to divide by that yet. We want to have divided by, let's see if I can do this, 0.1 minus 0.028. What's that? So I get a 1.011. So it's pretty close there. If you need help with that quadratic equation, it does get tricky. A lot of times I have to do it more than once. And I know I did give you the even numbers for these problems, so I'll put the answers up there for you. But try those weak acid problems, and let me know if you have any questions. Good luck.